Hello everyone, it's January 31st. We're going to do the challenge for tomorrow. Well, first thing first, I got an offer for the summer internship. So everything moved very fast. I had an interview on Friday, and I had a second interview today, and then they already extended the offer. Very nice of them to do so fast. I mean, in the past few weeks, I was worried. I want to find an internship this summer and to boost my resume and also earn some bucks. But it didn't have very good chance. Didn't have very good response from all the application I've sent. But honestly, this time around, it was a lot more successful. I mean, the first time I tried this in 2019 summer, after I just started doing the computer science stuff, it was brutal. That time, I think 200 plus applications I sent, and nothing, got nothing. And eventually, I was able to get an internship from some connection. Not the best way I want to approach this type of thing, but got my foot into inside the door. And this time, I think in total I only applied for maybe 40 or 50, and then I got a hit. So yeah, it was pretty good. It was a nice place, and the place I really want to be. So yeah, I think it was good. It was good. All right, just got my cat out of the bedroom. All right, so let's start. Best time to buy and sell stock. Good old question. Good old question. I remember last time I had this question, I solved all five. I think best time to buy and sell stock. I think this is the easiest of them. You're given an array, for choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Maximum profit you can achieve from this transaction. Yeah, I think this is Cardane. You can do this by Cardane, if I believe it correctly. We find, yeah, this is Cardane, and we find the difference array, right? We find a difference array, and all we need to do is find the maximum subarray sum, and that shall be it. Yeah, but I think we can do this using the state machine as well, right? So we say you buy once and you sell once, right? Yeah, let's just all this type of question. Let's just go back to state machine. So we have a empty state and a holding state, right? An empty state to holding state we can buy, and holding state I can do nothing, right? And then from holding state to empty state we can sell, and in the empty state we can also do nothing. Therefore, the initial empty state and a holding state. The initial empty state profit shall be 0, and the initial holding state shall be something. So one of them should be minus infinity. I think the holding state is minus infinity. And we can just say empty state will equal to the maximum. Well, empty state will do nothing. Or, and because we only I can do it. Is this by a once? Yeah, I think this is by a once because I don't have e by itself. So the empty state is always a cell, so it's the previous holding state cell plus the thing we sell, right? Plus, well, no, by a cell plus the thing we sell. Therefore, yeah, so that's that, and then the holding state will be the maximum holding state itself, and empty state minus the price, right? So, and we have to buy one and sell. So if I buy one, I can choose to buy at any day, and I sell can choose to sell at any day. Yeah, I think that shall be it if we use this. Okay, let's write it out. Oh, wait, hold on. We have to make new directory. 2. And then copy 2. New month. Time flies, like blink of an eye. January has passed. Very soon we'll reach summer, and then next semester, and then boom, then a year has passed. I'll be 1 year older. Ha! Import mass. Yeah, I think that's the start, right? And then for P in prices. So, but hold on, this is to buy and sell infinite number of times because you are allowed to buy. Because what if I allow to buy only once? Yeah, I think it should be different. What if I only allow to buy once? If I allow to buy once and then choose any time to sell. So if I buy, so we shall say the holding state. Yeah, empty state does not go inside holding state because if I go empty, that's the end. This doesn't go. So holding state is either do nothing, but if we do nothing, then we don't. So either do nothing or we buy. So shouldn't, like, every time I shall try to buy. In minus p, right? So every time is minus p. And the empty state I can wait. When I sell to empty state, and that's the end. Yeah, we cannot go from empty state to the holding state. We don't buy again. So empty state is equal to maximum empty state and holding state plus p, right? But holding state is different story. Holding state shall be maximum holding state, right? I can choose not to buy, like continuously not to buy, or minus p, right? I can choose, or is it just minus p? Or the maximum of, yeah, I think it should be, and then we shall return empty state, right? Okay, let's see. So this one shall be 5, and this shall be 0, which means return E if E is larger than 0, else 0. Yeah, I'm actually not sure. Even if I've done this so many times. Every time I do this, I feel like a hack. Yeah, I think this is correct. So it was right. Okay, how about we check, let's say, the price is 1, that shall be 0, right? Because I buy, I cannot sell. Yeah. And then we're gonna do Cardane, because I just did it some other day. So Cardane shall be fine. So this is 21, this is state machine, right? State machine method. When and costs us a whopping 1356 milliseconds with a 41% ranking. Alright, so we're gonna do Cardane. Now Cardane requires, so let's try Cardane. Cardane's algo, which, if I think about it, we're gonna go one by one, right? And we just want a maximum profit. So we're gonna have max P, maximum profit, equals minus math.inf, and we need a current. Not current, it's just the previous profit equals, I don't know, what's the previous profit? Because buy 7, sell 1, right? So it's going to be this minus this. And I'm going to start from this position. And then it's difference, 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 and difference, right? So this shall be, let's say minus the first one. Minus 7. Minus infinity, actually, yeah, it can be minus infinity. Yeah, let's do minus infinity. Let's also do this as a minus infinity, that's the previous, right? And then what we need to do is for I in range, it has to go 1, the lamp price, right? Has to go for 1 to lamp price, and we're going to say find a difference, right? And then we say the difference, so diff equals prices I minus prices I minus 1, right? I'm going to say if, I'm going to say pre equal to maximum diff or diff plus pre, right? So now I got a pre, and we say max p or equals max p and prep p. And eventually we're going to return a max p if max p is larger than 0, else 0. And I believe these two we can just write in one line for cheeky reason. Okay, so this is Cardane without the need to create separate. But if you think about it, this is actually, isn't this the same? Minus, minus, right? For every single one. Yeah, diff plus pre, diff plus pre. Well, slightly different, but I mean the algorithm is slightly different, but the overall I think is the same. Yeah, it's the same idea. So it's Cardane. All right, so we're done with this. I don't have to spend too much time on it. Really, I want to spend time is, this is the contest from yesterday, not yesterday, from Saturday, right? This is Saturday's contest that I failed. I failed to reach this problem. Didn't even do this problem. This problem, the last problem. All right, let's see. Oopsie doozy. What we have is something I do not like, which is string. String is not, definitely not my forte. You're given a zero-indexed array of strings words. Each string consists of a lowercase English letter only. No letter occurs more than once in any word. Two strings, S1 and S2, are said to be connected if the set of letters of S2 can be obtained from the set of letters of S1 by any one of the following operations: adding exactly one letter to the set of letters, deleting exactly one letter from the set of letters, replacing exactly one letter with any letter, including itself. Why would you replace including itself? Then you're not trying to change anything. The array words can be divided into one or more non-intersecting groups. A string belongs to a group if any one of the following is true. It is connected to at least one other string in the group. It is the only string present. It is the only string present in the group. What does that mean? It is the only string. Belongs to if any one of. Oh, I see. Either you have multiple strings and then every one at least connected to one other, or the group contains only one string. And then the strings should be grouped in such a manner that a string belonging to a group cannot be connected to a string present in any other group. It can be proved that such arrangement is always unique. Return an array answer of size 2 where array answer 0 is the total number of groups can be divided into, and array answer 1 is the size of the largest group. I think I understand what it means. Okay, so if the two are connected, so basically what we can do is first we find who are connected, right? S1 and S2 are connected. If the set of letters of S2 can be obtained from S1 by any one of the following operations. So either add, delete, or replace. So add, okay, delete, okay. So if they have different size, right? If S1 and S2 has different size, then we need to try add or delete. If they're the same size, then we can try to replace, which means they can only differ by one. So we can build a graph. Let's see the examples. So 0 and 1 can be replaced, right? 0 and 2 can be adding. Oh, and it's mutually. Wait, is it mutually? If 1 and 2 can be connected by adding something to 1, right? That means we can remove something from S2. Deleting it. Yes, so the connection is mutually. It's mutual. 0 and 2 is good. 0 and 3 is no good. So 0, so we can actually build a graph. We say we have 0, 1, 2, 3. 0 to 1, and a 0 to 2. All right, and a 1 already done. So 1 and 2, okay, and 2 and 3. That cannot be. So in total, we have two groups. 0, 1, 2 is a group, and 3 is a group. And the size of the largest. Yes. All right, let's try this one. So we have A, AB, and ABC. So A connect to AB, but A do not connect to ABC because that's differ by too much. And then AB can connect to ABC. So we have one group with 3. So shall return 1, 3. This doesn't seem to be too hard. And words consist of lowercase English letters only, and no letter occurs more than once. So every letter is unique, right? Every letter is unique. So we can set them. Wait, which one will be the easiest way to tell if they differ by exactly 1. Set, right? Set. We set them and we do a minus. Not minus, what's that called? Yeah, we do a minus. Set can do minus. Hold on. Yeah, I'm going to use set. Let's say A equals ABC and B equals, let's say AC, okay? And we'll say set A, set B, right? I will say set A minus set B. Yeah. So it has to be 1, right? 1 that differ by 1. So we can go through everything and run this algorithm to obtain the adjacency list, right? So adjacency list will be 0, let's say go to 1, 1 go to 2, and of course 2 go to 1, and 1 also go to 0. So it'll be like this, right? But then the question is, basically the question is how to find, is that called a clique, right? How to find individual group. How do we find individual group? To find an individual group, and of course we can see some does not have connection, so those by themselves, right? Okay, so those got removed, and then I am just going to, I think we can just traverse, right? And this traverse is going to be not, we can do DFS, but I feel like BFS is more efficient, right? We can go BFS from one spot, BFS, right? Once we're done, pick the next one, BFS, and then I don't think this one is that hard, but the acceptance rate is only 20%, which I am not sure why, but I'm gonna give it a shot. All we need is an adjacency list, right? We need to build an adjacency list. Okay, so here's how I would do. So adjacency list, right? It's going to be a list, right? It's going to be a list. And then we say for wait a minute. 2 times 10 to the 4th. If we build this, maybe that is the challenge. We're going to time out. This is going to be O(n) squared to build the adjacency list. Can we build it faster? Let me think. So we have to know all the connections. Hold on. Let me think. If I have one thing connecting to everything else, and they must all be together, right? But one thing we can use bitmap, I just realized, right? Bitmap, that just means if we exclusive OR the 2-bit map. So if they differ by 1 with exclusive OR, then I shall return with only 1, 1. Alright? If they're the same length and differ by 1 letter, then exclusive OR. So if they have the same length, right? We have the same length and they differ by 1 character. Right? The same length and they differ by 1 character. Then if I exclusive OR the 2, then we shall get 2 ones. But we still have to go through every single thing. I'm not sure, but I'm gonna try. I have to do this anyway, so it doesn't really matter. Alright, range woods, and this one will depend this, right? And then for j in range I plus 1 to, we have to go n. Yeah, this I'm not so sure about this part. Alright, so we say if len woods I, if len woods I is minus len woods j, I use ABS, right, is smaller or equal to 1, then we can consider, right? And how we consider is we're going to turn everything into wait, will the same word appear twice? Ah, it can, including itself. Yeah, I know, this doesn't have duplicates, which is fine, right? Let's just do the set. And we should say if we need to go if len woods I is larger or equal to len woods j. Yeah, because if not, then we have to loop through every single one. Just a little bit more trouble. Yeah, just do this way. If this and say set woods I, right, minus set woods j, and we're going to take a length of this. If the length of this is smaller or equal to 1, right, then we say adj minus 1 $pen j. Elif, same thing, right? Exact same thing, we just change I and j. So if j is larger than I, elif j is larger than I, and j minus I is smaller or equal to 1. And we also do the same. That's the only 2 situations. Any other situations we don't consider. And this actually goes, we just use larger too, which would be fine. Actually, it'll be easier to identify, we're just to smaller than this, and j minus this is smaller or equal to 1. Oh, it won't be the same, so it just has to be equal to 1, right? It has to be equal to 1. So if this, out of this, all the other situations we don't add. So once we're done with this, right? Once we're done with this, we'll get the adjacency list, right? Now we just need to, I don't know, we need to do the what should we call it? We should do the DFS, BFS. I have to do BFS. So what we're gonna do is for every single one. So we're gonna have a node set is gonna be set range n, right? Let's actually see if this one works. So set range, let's say 10. Oh. Yeah, it works. So we get a node set, right? And then for I in range n, right? Now for each one, we're gonna say let's say res equals how many should we do? Oh, let's go -1, -1. That's fine. All right. And we say if adji, if not adji, which means it's by itself, then hold on, which one is the size? Total number of groups. So first one has to be 0, right? If not, then we say res 0 plus equal 1, and res 1 equals max res 1, 1. Okay? Else, now we have something, right? We have something. Well, actually, elif I is in node set, but not visited. Not visited, right? If it's in and not visited, then we're gonna say q will equal to I, right? We just visit everything, however much we can do, and we just say while q, I'm gonna say count is equal 1. Oh, count is equal to 0. While q, and temp is equal to this, and say for node in q, every node come out, count plus equal 1, and not visited, I'll remove node, okay? I'll remove node, and so I remove it from not visited. Why would you say not visited? It can be visited. Now the idea is if we get to something and it's visited, then we don't visit it again. Yeah, why do you say not visit? I don't know. That is weird. Just visited, right? Visited equal to set. And then if are not in visited, then blah blah, and then we say visited.add node, right? For node in queue. Actually, I don't like. I want to check beforehand. But if I not in visited, and then visited.add I, count equal 1, count equals 0. What would be the best way to do this? Hold on. No, I don't like this. I like this. And then for node, if node not visited, then we handle it. And then for neighbor in adjacency list node, temp.append neighbor, right? And then blah 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 blah. Once we're done, Once we're done, q equals temp. Go back, go back, go back. So now we have a count, right? We have a count. So this will handle all the, inside. Okay, so when I say res 0 plus equal 1, I think, yeah, it's fine. Res 1 equals max res 1, and then count, right? And then at the end, we just return res. All right, let's see. I feel like if this one fails, most likely it's gonna fail because, I don't know, because it's too slow. I think that's the only case. Actually, I'm not sure. All right, 1, 3. Let's see, so we have words. What's this? Group strings words. Fail. I have 3, 3, and 2, 3. That is interesting. The number of groups. Huh. How do we get more? All right, so before we start, let's take a look at JSON list. A has 1, right? ABC is not counted. Why? Because I forgot to do. Shoot. I know. All right, I know. It should be this for this in range n. And then because of that, when I do, I can just say this j and the JSON list j dot append I, and it's exact same thing that happened here. Which honestly, we can just, how can we combine this? Well, the easiest way is actually turning into bitmap, but I feel like bitmap requires a lot more effort. Yeah, this will be correct. But hold on, why I have so many more? Oh, I should not do this. There we go. All right, now the only fear is this one's too slow. That is the only fear. Do I have test case? I don't know. Oh, test case by itself, definitely a good one. Test case, same thing. All right, let's do A again. Now do BC. Now do BC. Word length of 26. So this part should be fast. The slow part is I have to do a O(n) squared to build up the adjacency list. I'm not sure how lenient the online judge is, which I think is not lenient. I think we got TLE. Damn. TLE on both. That is just brutal. Oh, wait. So, yeah, that's, otherwise it's too easy, right? All right. what we can think. Yeah, I'm pretty sure. Oh, what a test case. Okay, so with this test case, I just want to see how long it takes to run. I need to know if this is a good benchmark. Yeah, I think it's the first part. It's this part. 3 seconds. It took 3 seconds. We can profile this. Kind of see if this can help. Nah, I think the issue is with this for sure. Like I can comment out the entire thing, right? And I say, and also comment out this, and I just say return 1816 and 1314. I don't know, see how long it takes. Kind of see if the issue is on this first part or on the second part. Yeah, it's on the first part. All right, so we need to make this one faster, which means we need to build. Okay, we need to build this whole thing faster. How do we do that? Bitmask, right? So for 26, let's say A, B, C, D, it doesn't matter. For this one, A, B, C, D is also 4, right? So 1, 2, 3 is A, 1, 2, B, and AB, and A, B, C, D. So C, D, oh my god, it has an E. Okay? So what we want to know is who belongs together. I want to know that fast. Okay. How do we know that? Well, if exclusive or 2 values, and the answer is two ones, right? How do we know which one might belong to each other? All right. So I look down on this, right, and I have n of them. Anyone that is a 0. Okay, anyone that's a 1, even though that's a 0, that's already one difference, right? So we can only allow one difference. Hold on. If given 0, 0, 0, 0, 1, right? The only possibility for the others and the length for each has to be, there's no possibility for a empty string. So it's going to be 1, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0, 0, 1, 1, right? These are different by 1 because I am 1, right? I exclusive OR with someone I want it to be So the last letter is the same. So which means the other, we can add a 1, right? So add a 1 at any position. Or it could be exactly the same as me, right? Or, yeah, I think that might be the case, is not to go this, but find all the possible pairs using bitmask. So I given a bitmask, I need to find what are all the possibilities. Well, so they have to match, right? So they have to match, and then I can take a 1 away, right? Or we add a 1. Or, okay, so take 1 away. So that's 20, at most 20, 25 different possibilities. So we have 25 possibilities, and we add 1, at most 25 possibilities. And for replace, so have the same. What does replace do? Replace. Ooh, replace. If we want to do replace, that means another one is exactly the same, but if it's 0, but we put 0 on 1 and put 1 in another position. How do we do that? Now every 1 can turn into 0, every 0 turn into 1 at a time. And then this one is, I have a lot of different options. Like all the 1s and all the 0s. We need to find pairs. Like seriously, we need to find pairs. How many 1s times how many 0s? That's a pair. And each pair I can turn to 0 and turn to 1. Right? What's the maximum possibilities of that? I have 26, right? If we have 1 0, if I have 1 1, everything is 0. So in order to do this, is the 1 becomes 0 and become 1. So it's 25. The minimum is 25. The maximum shall be how many 1s times how many 0s? So it's 13 1s and 13 0s. That's 169. So 169 maximum possibilities for the swapping. But if it's 169, then for all the 0 terms, that's only 13. So plus 13 plus 13. So that's 195 different possibilities. And for the other end, we have 25 times 25 times 10 times 3. So 75. So it's like 75 to 1. Yeah, 75 to 169. Now 169 plus 26. Now 195 times ON. And that's not ON squared. So I think that is the solution. So what we need to do is to, madre mia, we still need this, but we need to first convert, right? So convert words into bitmask, right? So bitmasks equal bitmap, right? Bitmap, not bitmask, bitmap. So when you say bitmap will equal to, for word in words, right? It's going to be a set. What do we do? We're going to say for word in words and sum for letter in word, right? And each letter we can go ord, right? Ord a letter minus 97. That's how many shifts we need to do, right? That's how many shifts we need to do. So just one left shift this much. So that's the bitmap, right? And once we're done, we simply grab each bitmap, right? We're gonna grab each bitmap, and we can do that because we can say for bm in bitmap, right? We'll go through every single one, and then we just loop through all possibilities. All possibilities. Huh. They're all unique. So the adjacency list is not recording. Everything is unique. Nah. Not everything is unique. You can have duplicates. So I can do this, right? Bitmap. I still want to build a. You know what? I don't want it to be a set. That's actually gonna make things more difficult. I want to make it a dictionary. Okay, so that's gonna be a dictionary, and this is gonna be I, W in enumerate words. And I still want this part to be associated with the index because the value itself can be duplicate, and an index is much easier to handle. So sum this is the bitmap, and that's gonna be I. Okay. And for bitmap, for bitmap in this, hold on. One bitmap can have multiple. Holy guacamole. It can have multiple. What if I have duplicates? Right? Yep. I can have duplicates. So let's say bitmap is just going to be this, right? And I just deconstruct this whole thing for this. And for letter in W. Now the bitmap can be computed. That's fine. That's never a problem. Right? So this for the current word, we can find a bitmap. And we basically just say bitmap this dot append I. Okay. Once we're done, we throw this out, and for each bitmap in bitmap, all right, for each bitmap in bitmap, we're gonna find the other bitmap that is possible to be its connection. And once we find it, we need to, we just find it. How do we find it? So what we need to do is we need to find which one is 1, which one is 0, right? That's what we need to do. And we can go right shift, right? Right shift to 1. Well, right shift 0 and map with 1. So it's going to be 0. So we know that is 0. So we go 0 to C. Okay. And if it's 1, we go for 1 to C. Okay. So these are fine. But how about the replacement? Oh my god. Replacement. How do we handle the replacement? I need to have all the indices for zeros and all the indices for ones, right? And then for one index is 0, and we find a 1, and we swap the 2, and the next one we swap the 2. Well, actually no, if it's 0, that's 1, and if the 0 is 1, then we need to swap 0 become 1 or 1 becomes 0, right? And then we try to find if it's inside bitmap. Holy guacamole. Like everyone hold up. So bitmap, for each bitmap, everyone will be linked to everybody else, right? Yeah, everyone will be linked to everybody else. Hmm. Zero position, right? Zero position or one position. And it's gonna be this, right? And then hold on. Let me think. If we have two is exactly the same, they can be combined together, right? They can be combined together. Yeah, I don't need to do one of them. Yeah, and then the other one can remain empty. It's fine. Oh, I cannot. Just put everything in there, even with themselves. I think it's fine. Right? Because as I was searching, yeah, yep, yep. I do not include myself. Myself is already included here. Okay. Uh, all right, let's try this. All right, so for I in range, yeah, it's fine. For I in range, what? 20 shift to 0 time, right? Shift 0 time, shift to 1, so 26. So this is a um, BM, remove one letter. So remove one letter, right? Remove one letter, we just say if it's if bm right shift I and 1, right? If this is positive, then we turn it into negative. So this is to remove, right? This is to remove one letter. Then we just say if, so first of all, that's one position dot append I. And then we say if bm or 1 left shift I, right? bm or this is inside the bitmap, right? Is inside the bitmap. Then we're gonna say adjacent I dot extend, right? It's dot extend, but we can just do adj adjacent I. No, it's not adjacent I. It's adjacent matrix bitmap. That's what I need to use. Hold on. So everybody needs to extend. Okay, so everybody needs to extend, which means for j in bitmap bm, alright, for j in bitmap bm, adjacent j dot extend adjacent j dot extend dot extend something. Send a bitmap dot get bm 1 left shift I. If nothing, it's just this. Okay, so remove one letter. Okay. Else add one letter. Remove one letter should be exclusive for. This current is 1, right? So remove one letter. Now we add one letter, which means the current is 0, right? So that's why I should say 0 position dot append. And for j in this dot extend, in this one we add one letter. Alright? Everybody add this. Okay. So after this, I will get a 0 position and 1 position. And then what we're gonna do is for ij we use, right? So for I in 0 position, for j in 1 position, right? So we just, the 0 position becomes 1, 1 position becomes 0. Then we say this for k in bit map bm. Okay, let's let me use two different pq. Let's say p in here, q in here, and for j in bitmap bm adjacent j dot extend bitmap dot get something. And this, what is this something? Well, it's gonna be bm. The 0 to turn to 1, so we're gonna or 1 left shift p. Yeah, let me just put extra parentheses. I am not 100% sure. So I'll put extra. So or this, right? And exclusive or one left shift Q, because Q is 1, right? So we turn 1 to 0. So we do that, right? So once we've done this, so this was a at one letter, remote letter, replace letter, right? So we always pick a 0 and pick a 1, right? We swap. Pick a 0 and pick a 1, we swap. And by the time we're done, it's all 0 and 1, 0 and 1. So I have also the last part. Right? The last part is extend itself. How do we extend itself? And then it's a bm, right? So bm for every single one. So extend itself will be for j in bitmap bm. For j, it should be to remove j. Hi, how do I do this? Well, I can say for each j in this, JSON j dot extend JSON j dot extend. But this one can run a long time though. Like these is finite. Yeah, well, extend might not be finite. But this one, I don't know. Maybe just extend itself. So we do a bunch of this, and then we say if bitmap, if len bitmap, ideally we'll extend just all the ones without I, right? Just extend all the one without I. So we say dot extend. Extend what? This for k in bitmap bm. It's exact same thing. If k is not equal to I, not equal to j, and we do k. Right? So we're going to extend, and extend. Once we're done, then we do this. So the adjacency list is exactly the same. And we run. Syntax error. Of course, because it should be this. Key error, where? Key error 1. What does that mean? For one thing, this has to be defaulted. And then we'll call it default vector with list. My bad. Here. So it should not be here. Yep, that's the same. And can we make this better? I mean, technically we can, but I kind of don't want to. Okay, let's make this one slightly better. Right? I is not in visited. Then Q is this, let's say count is 1, and I visited at I. Okay? And then la 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 for no is definitely not for node in Q. Right? Now we don't do it here. We do it here. For node in Q and for neighbor. And we say if neighbor is not in visited, then visited.add neighbor and count plus equal 1 and attempt to do this, which I think is the same, but the benefit is the temp can be smaller, so we won't have duplicates here. And at the end, we do the same thing, we do the max. Okay. So the hope is this can significantly reduce the runtime. So instead of 4,000, I hope it will be reduced to maybe a couple hundred. It is not correct. It is faster though. It is faster. Okay, but we have error. I think that is the idea, but we do have error here. That would be tragic. How do we handle this? We won't be able to know. A small test case will be correct. Yeah, exactly, I know. A small test case will be correct. So we need to hunt a test case that will give us wrong. Where do we get wrong? One left shift letter, right? And then we sum them together. That looks fine to me. One left shift this for letter in word. And everyone's unique. It's fine. And then we sum them together. And then that will append I, which is the index. And then for BM in this, I need to find all the 0 position and the 1 position. How do I find a 0 position and 1 position? I say BM right shift, right? Right shift I and add 1. If it's a 1, then that's a 1. This position is a 1. So for this position, I want to exclusive order it, so it will become a 0, right? And I check if I have any. And for every bitmap BM, I am going to say, okay, this one can get to this position. Now the 0, I use OR, because I need to take that into 1, right, and extend this. And for P in 0 position and Q in 1 position, right, all the 1 position and 0 position, I can swap the 1, swap the 2, right? How do we swap? I say BM OR this, so all the 0 now shall become 1, and all the 1 position shall become 0, right? Because that's swap 1 letter, right? That's swap 1 letter, and at the end, we also do itself. I do not know, man. This is getting frustrated. Yeah, I definitely don't like this type, but I have no way. No way. Like, literally no way. I have to narrow it down so I can detect what has gone wrong. Oh, good. Narrow it down has worked, so we can keep narrowing it down. Somewhere here. Yeah, let's just delete all this. Run it. Oh, I got extremely lucky. All right. All right, this is a lot more manageable now already. Yeah, maybe, I don't know. Maybe it's possible to figure out what went wrong. But keep getting wrong. That's good. That's good. All right, last bit. Not really last bit, but we can let's try this. So the total number is wrong, and the largest is also wrong. Very good. Very, very good. Yeah, keep going on. 60 something. Now I believe the error must be critical. All right, this is not right. This is fine. How about we take the second half? Okay, this is the second half. Okay, good. Let's keep shrinking. Keep shrinking. What I can do is I will use the other one. Perfect. Maybe isn't enough. Expected 18 and 2. Output 19 and 1. There's one connection I did not specify. I did not find. Okay. There's one connection I did not find because of the method I used. Hold on. So let's say I have, right? What if I change this into a 0? So if I change this into a 0, and exclusive order 2 will be 1, right? I want 2 ones, right? I want 2 ones. So what I can do, I can change a 0 to 1. What if I turn another one to 0? Then this is not working. exclusive for is 2, 1, but the two has different length. I think this is good enough. Let's print something out. Okay, let's print something out. Anyway, this one answer shall be 18 and 2. Okay. Yeah, let's go back to the error, and I'm gonna pull my code out, and we simply just print. We print the adjacency list and see what happens. Like which part is wrong. So we're gonna use adjacency list, which is all this, right? That's the adjacency list for this. So we simply let me simply print adjacency list, right? Of course, we don't want these two. I just want the last one. That doesn't look good. That does not look good at all. The heck is this thing? Like seriously, what the heck is this thing? I think the issue is deeper than I had expected. Yeah, this is how it's supposed to be. Good lord. I got nothing right. 18. Oh, wait a second. Wait a second. This is not right. Alright, it's weird. Let's not print this one. Let's print the bitmap. Okay. The bitmap looks right. There's no duplication, so everyone occupies one. So the bitmap looks good, right? The bitmap looks good. But the adjacency looks just absolutely bonkers. And I don't even have the 16 and 15 connection. All right, let's see. Did I get extend wrong? Hold up. Let me print every single time. Right? Print adjacency list. Yeah, I got a bunch of zeros. I got a bunch of ones. How? I am sorry. I need to get down to the end of this. I'll just print adjacency here. Then we got a bunch of extend. Alright, I need a BM, right? Well, actually, I need a bit BM, bitmap BM, kind of know where I am, which one I'm looking for, I'm looking at. So I'm looking at 0. Okay, I got nothing. Okay, what's 0? So 0, I got nothing. Fine. Now I have 1. Okay, and 1, I say I have I'm looking at 1. Doesn't make any sense. I'm looking at 1, right? And j, how is j equal to 0? What? What if I print j? J is 1. There must be something happened here. K in bitmap. If k is not equal to j, I don't understand. Why do we get all these zeros? Where did they come from? Maybe it's easier to check this. Yeah, that's also weird, right? After every time, I should print. Let's print adjacency list after every single time. Let's kind of get an idea of where things went wrong. I'll print it 3 times. So 1, 2, 3. Okay. So 1, 2, 3. So I'm at 0, 0, 1, 2, which is add. Okay. That doesn't mean or remove. I'll add one letter. Yeah, we got it. And then replace letter. Replace. 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 This is 0, 0, 0, 0, 1. Okay, that's a 0, 0, 0, 1, 1. So replace. How do these two match? How can I replace? I say when I replace is all the 0 position, right? So P in 0 position and then 1 position. So it has to be 1 something something 0, right? And then this has to be 0 and then this has to be 1. Right? That's the only, like, they all not equal to, they're not equal to B. Oh. Yo, man. That is stupid. But still, it's still not right. Okay, that is still not right. Even with this, that's still not right. Which maybe I don't know. We add another parentheses. Oh, it is add another parentheses. It has order. Wow, it has order. So exclusive or executes first? Man, I don't know that. Ah, in the future, definitely, definitely. Oh, it has order. Python bit operator order. Hmm. Nah, shouldn't I just say operator precedence? Yes. As highest precedence, function call, blah blah blah. Bitwise. Exclusive or is before all. So in the previous case, exclusive or before all. So exclusive or first. Now I'm pretty sure this one shall be correct. Yep. Yep. So the problem is not with the idea, but with I'm not so sure about the operators. I mean, in this case, I don't need, because they have higher precedence than the bitwise operator, right? So I can safely remove all the parentheses, which shall be fine. And we can do this, which shall be fine as well. Okay, so I can solve this problem, but in the contest environment, it could be tough. I can see how this can be tough, like very, very tough. But it's fine. Está bien. All right, let's see. Do we got a correct answer? It only takes 312 milliseconds. I think this one will pass. Another TLE? No way. Not good enough, they say. Not good enough, they say. How long? Wow, this contest is filled with TLE. It's definitely faster. 800. It's 800 milliseconds. It's definitely faster. I think. Wait, what's the last run? Last run was. I don't remember. Oh, here, 73. I go past 73. How about this time? 87. I got 10 more test cases. Just 10 more test cases. They're all huge. Okay. Okie dokie. Maybe it is time to re-examine this. Right? And this is ON. Server is visited once. Okay, can we do something while we're here? I don't know, man. I honestly don't know how to improve. If it's 1, I remove one letter, now it'll be the same, right? I don't see how it can change. Hmm. Well, if the adjacency list is also a default dict, right, then we can avoid something. We can avoid something. So what I'm suggesting is we only need to handle one. We don't have to handle all of them. That's the last part that I think I can make a difference, which means this I'll do simply default dict. Hold on. Default dict list, right? And then, right, and then instead of going for everyone, I just go for one, right? I just go for one. The bitmask is this dot append. Okay, yeah, this we do need to append, right? We do need to append. And but here, all we do is adjacency list. Let's call it bit map bm 0, right? Only one of them dot extend. Okay, only one of them dot extend. The same thing happens, but here only one of them dot extend. Okay, and it's the same, only one of them dot extend. Okay, and here again is the same, only one of them dot extend. That'd be easy to say. We dot extend from that VM 1 to the end. Okay. So once this is done, right? This is this, and then we go this, right? And we say if not, right? If it's not in it, if I is not in adjacency list, oh, I cannot do that. I simply cannot do that because those are duplicates. For BM in bitmap, right? Which means every letter we can do this, right? Every letter we can do this. And then that will extend. Hold on. Actually, I'm not sure. Let's say from collections import default dict and a equals default dict list, right? What happened? Huh? Wait. Is that a bug in PT Python? Yeah. I think this is a bug. I found a bug. Huh. Alright, anyway, so a, let's say, 1 dot extend this. Yep, we have an empty, which means if I'm only using this, so those are not. So hmm, if I not, yeah, now I don't have to worry about I, right? So I can just go through the adjacency list, right? For I, so I just say go for I in adjacency list, and we say if not adjacency I, then we do this, right? If we have, then we go through. Then we can, if we have a duplicate, basically this one can solve the duplicate problem. So I'm reducing the amount of efforts. Right? So there's not that much duplicate to handle. All right, I think this will be the last try, and then if it's still not giving me good result, I am going to call it a day for today. Change size. During iteration. Did I change size? Wait, what? I didn't do anything to adjacent. What? How? I didn't change it. This is bonkers. I actually don't remember the solution. Yeah, I'll just put whatever. It took a long time, man. It definitely took a long time. And it tell me that it changed size. Dictionary changed size during iteration. Huh? Where does it change? Oh, what? Okay, how about our keys? I didn't do anything. I didn't do anything. Like, honestly. I don't know, man. And this will make it slow because I have to go through every single thing. Man, I don't understand. What do you mean by dictionary change size? Ah, and it's not correct. It is not correct. The previous one was correct. This one is not correct. And it's actually slow. Yo, the previous one at least is correct. I got this one right. I got a number of output is wrong. I don't know. So what I'm saying is, let's say b is equal to 1. It's equal to 2. Right? And we say a, b 0, right? Dot extend what? Dot extend b 1 to the end. Yeah, that's right. Which means these has no other friends. They don't have friends. And I always use the first one. So the second one is like I'd ignore. And then it's dot extend. This means they're the same as me, right? So I just more on them and done. So these actually does not exist in a JSON. Right? So they does not exist in a JSON list. I not in visited. Okay. Neighbor in adjacency node. Oh, I see. I see why. Hmm. I see why. I see why. I know why. Okay. So we're still gonna go for I in adjacency list. We're gonna change, right? For neighbor, if neighbor not in visited, visited this, whether we add neighbor, or we can add neighbor. So for node in queue, right? If node is in adjacency list, then we do this. Yep, this one correct. But A965 3354. But it's what should I call it? I don't think this one is. I don't think this one cuts it. 800 milliseconds. I need to be significantly faster than 800 milliseconds for it to pass. 700 milliseconds. Is this one sufficient? Holy guacamole, it is sufficient. It is sufficient to pass. Wow. 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 3 wows. Wow. Okay. What a journey. Alright, I think I'm gonna end it today. I definitely need to look at the discussion tomorrow, but I feel proud that at least I solved this, even though the runtime, I think I've never had a runtime that bad before. 2000. That's what's supposed to be. Damn. Yeah, look at this part. Jeez. I mean, let's do one more, okay? Let's do one more. What we can do is we can use a deck, right? So we can call Q a deck count related, and then we just a while Q. We don't have to do this, right? So for node in Q, if node in this, and if a neighbor in this, yes. If neighbor not in visited, visited add, and then deck.append. And that's actually we doing while Q. We actually just say node equals Q dot pop left, right? And then if node blah blah blah, then we don't have to do this. I think this one's still pat. Invalid syntax. For sure it's invalid. Append. Oh, it's not that. My bad. It's Q. Oh, it take a long time. But let's see. So with deck, the benefit is I think it will be, I don't know, let's see. We're gonna make it slightly faster. Let's try this one. 470 milliseconds. Can we cut it down to, let's say, 500? No, it did not. It bloody did not. Now let's try with a deck. Where's the deck? Okay, it's faster. It's faster with a deck. Okay. All right, I'm gonna write something, and but I'm gonna call it. I'm gonna just write it offline. And let's write it. It's fine. It's fine. So the idea is quite simple, right? The idea is quite simple. First, build a graph of all the words, and then use BFS to find each group and group size. Now the difficult part is not the BFS, at least I think so, but the construction of the graph. Now the naive way to construct the graph requires ON squared, right? Which is too slow. The method used here is bitmap. Is here turns each word into a bitmap of size 26, and then we create all possible connected words, which does not exceed 200, right? Which does not, which is only a couple hundred, which in the worst case, right? In the worst case is only a couple of hundred. And then we check whether such connected words exist in the original words, and from there we construct the graph. That's ON. Yeah, ON with a huge constant. The runtime is terrible runtime. But this one scores 16%. Okay. Now one more thing. The operator precedence is left, right, shift ahead of and ahead of exclusive or ahead of or. Okay, so I'll end it right now, and tomorrow we're gonna pick up right here. I'm gonna go to the discussion and see how other people do it. UnionFind. 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 Okay. And DFS. We'll check this tomorrow. All right, I'll see you guys tomorrow. Adios. UnionFind.